Let's continue with our playlist. But before that, hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is sorting a given linked list which has zeros, ones and twos in it. So what is the problem stating? It is stating that you'll be given the head of the linked list and this linked list only has 0, 1 and 2 in it. Your task is to sort this particular linked list according to the data, which means initially there will be zeros, followed by ones, followed by 2. Once you have sorted this particular linked list, you'll have to return me the updated head of this particular linked list. So what if this problem comes up in an interview? You start off with the brute force, and what is the extreme naive solution that you can think of? Data replacement. What you say is, we just have zeros, ones and twos. So what we can do is, we can take count 0, we can take count 1, we can take count 0 and initially have them initialized as 0. After that, we can do a single traversal. Maybe we can keep a temporary pointing to head. And whatever is the value of temporary, in this case it is 1. First occurrence as 1. So you go and increase the value. After that you move the temporary to 0. So it is 0, so you increase the 0 by 1. Let's again move it, it's 1. So you increase it to 2. Let's again move it, it's 2. So you increase the 2 by 1. Let's again move it, it's 0. Let's increase it. Let's again move it, it's 2. Let's again increase it. Let's again move it, it's 1. Let's again increase it. After that, move it again. It is at null. The moment you reach null, it means the traversal is completed. Once the traversal is completed, I can say that the count 0 is holding the number of zeros, count 1 is holding the number of ones, count 2 is holding the number of twos. So after the initial traversal, you have count 0, count 1 and count 2. Now it's time to do the data replacement. So what I'll do is, I'll do another traversal. I'll take the temporary, place it at head, and what I'll check is, what is the value of count 0? Does it have any zeros? It says that I have 2 zeros. So let's take 1 and place it. The moment you take 1, you reduce the value to 1 and then move the temporary. Again you check, hey count 0, do you have something? It states that, hey, I have something. So I'll take that, place it and reduce the value and then move. After that, when temporary moves here, you check with count 0. Does it have any 0? It states I do not have any 0. This time I'll look at count 1 because after 0 there is 1. It has 3. I'll take 1, yes. I'll take 1. I'll reduce. I will move. Again, when temporary is at this particular node, you again check, is count 0 there? No, there is no count 0. Is count 1 there? Yes, there is. So maybe just place it, reduce it and move it. Again do the same thing. Count 1, take count 1, place it, reduce it, move it. When you're standing here, you check for count 0. It is 0. You check for count 1. There is no count 1. You check for count 2. So there is count 2. So you take it, place it, reduce it, and then move it. Again, you check for zeros and ones. There are no zeros and ones. So you take the count 2, take it, place it, reduce it, move it. So temporary is at null. The moment you reach at null, you stop. So if you carefully look at the linked list, the data replacement has been done. So let's quickly write down the pseudo code. Again, you can find out the C++, Java, Python, JavaScript code. Links in the description. Make sure you check it out. So what is the first step? We have a temporary which is pointing to the head. We have counter 0 which will be counting the number of zeros. We will have a counter 1 that will be counting the number of ones. We'll have counter 2 which will be counting the number of twos. And let's quickly start the traversal. So the temporary will keep moving till it reaches the last, which is the null. And what will be the first step? If temporary data is equal to 0, I will say counter plus plus. Else if temporary data is 1, I will say counter 1 plus plus. Else it will be definitely 2. So I'll say counter 2 plus plus. Once this is done, I can move the temporary to the next, which is temporary goes to temporary next. And the while loop is completed. So this is my first traversal. After the first traversal, I can say that counter 0 will have the number of zeros, counter 1 will have the number of ones, counter 2 will have the number of twos. What is the next job? Again traverse and do the data replacement. So let's quickly do it. What I'll do is, I'll take the temporary, place it at the head of the linked list, right? After this, I'll say while temporary is not equal to null because I need to retraverse this particular linked list. And I'll check, hey, do we have a count 0? If we have a count 0, replace. So it will say temporary, your data will be replaced by 0. At the same time, counter 0 will reduce itself by 1. Similarly, if 0 is not there, then I go to else if and I ask, hey, is there counter 1? Do I have 1? If I have 1, that means maybe replace this to 1. Perfect. At the same time, do a counter 1 minus minus. What if there is no 0 and there is no 1? It will fall to the else. If it does, I'll say temporary data equal to 2, because if there are no 0's and 1's, it means there is 2. And then we will say counter 2 minus minus. Once this is done, once you have done the data replacement, we'll ask the temporary to move to the next, which is temporary equal to temporary dot next. And this is where the traversal will complete. So what will be the time complexity? Can I say it will be bgo of 2n? Why? Because one traversal is here while the other one is here. So if you're traversing the entire linked list twice, it will be 2 of n. So bgo of 2 of n is the time complexity. What will be the space complexity? Bgo of 1. And this is where the interviewer will not be happy. Why? Because you're traversing it twice. He'll ask you to do it in one pass. So we need to convert a 2-pass solution into a 1-pass solution, which means I cannot do data replacement. I definitely cannot do data replacement. What can I do? If I'm traversing once and I need to rearrange them, the only option is I change the given links. Yes, I change the given links. How can I do this? What was the final arrangement? The final arrangement had 0's at the start. So if I just take up the 0's, it had 0's at the start and it had 1 following that. So if I take up the 1's, these are the 1's. It had 1's after that. And also after that, it was followed by 2's, right? So let's take the 2's. So can I do this? While traversing, can I segregate the 0's? Can I segregate the 1's? Can I segregate the 2's? If I can do that, once I've done that, right at the end, I repeat, right at the end of the 0 can be connected to 1. The end of the 1 can be connected to 2. Once you have done this, this will be my head of the linked list. And this is what you can return. I can probably do this. And this is what I look to do, because I need to do it in one traversal. And this is the best that I can do. Store all the 0's, basically make a linked list of the 0's, have the 1's, have the 2's, and then connect them. After that, you can return the head of the linked list. So let's try to do it. So after I have completed the traversal, what am I looking at? I'm looking at a list 0, which will have all the 0's. I'm looking at list 1, which will have all the 1's. I'm looking at a list 2, which will have all the 2's. So I need 3 segregated lists after I have completed the traversal. So what I will do is, I will take 3 dummy nodes. Yes, I will take 3 dummy nodes. One for the 0, and I'll call it as 0 head. I'll explain you what is dummy node. I will take 1 for the 1. So this will be 1 head. And I'll take 1 for the 2. Since during the start, I don't have the list because I don't have any elements. So the list is empty. I'll initially assign a dummy. Just the start with -1. Okay. This is what I'll assign. And over here, I will call this as 0. I'll take one more pointer pointing to it. I'll take one more pointer pointing to it. I'll take one more pointer pointing to it. This is my dummy nodes. So these are my starting point for 0, 1 and 2. So we have the L0, L1 and L2. What is your next job? To traverse and attach it. So let's traverse. If this is 1, we attach it over here. If this is 0, we attach it over here. If this is 1, we attach it over here. If this is 2, we attach it over here. And keep traversing. This is what I will look to do, right? Let's try to do it. So I'll take a temporary and place it at the head of the linked list, right? What is the next job? Have a check. The value is 1. So that means it will go and get attached to the L1, the list 1. Let's do it. How can I do it? Remember, you will not create a new node. You will not create a new node. Instead of it, you will say, hey 1, because this is your dummy head. Hey 1, dot next. Can you be temporary? So what this will do is, this will take the next and point to this one, right? So for visual representation, can I say it will be pointing to this? Once you have done this, you say 1, can you go here? Because I always need to stand at the last. And if this is done, I'll take temporary and move it. Perfect. Remember, this is not a new node. This is not a new node. It's actually pointing to this. It's actually pointing to this. This one is just done for visual understanding. Okay, let's look at the next one. What is the value? 0. This time what you'll do is, you'll go to L0 and you'll take the 0 and you'll say 0.next. You should be pointing to this, to the temp. So do it again for visual purpose. I'm just writing it separately. Once this is done, you move 0 to the next. You basically move 0 to the next and move the temporary. Perfect. What is your next job? You look at the value, which is 1. So you again say, hey 1, your next should be pointing to this. This is why I moved 1. This is why I moved 1. So again, for visual purpose, draw it and move the 1. Perfect. Let's move temporary. What is the value? 2, which means L2. Let's take it. Again, 2's next will be pointing to 2. Visual representation. Visual representation. In real world, this will be pointing to this. Perfect. Let's take 2, move ahead. Let's take temporary, move ahead. What's the value? 0. Let's point 0 and then move 0. Again, visual representation. And let's move temp. It's a 2. Let's take 2. Again, point it here and then move 2. What's the next job? Temp will move to the last and it is 1. So this will be pointing to 1 and then 1 will move here and after this temp will move here. And this is where it stops. This is where it stops. So after the traversal, if you carefully observe, the dummy 0 head that you did take, its next is pointing to the head of L0. The dummy 1 head that you did take, its next is pointing to the first node of L1. The dummy 2 head that you did take, its next is pointing to the first node of L2. Right? One more thing. The 0 will be pointing to the last node of 0. The 1 will be pointing to the last node of 1. The 2 will be pointing to the last node of 2. Please observe this because it will be helpful while we write down the code. Where will the 0 point to? Like, where will the 0's next point to? Can I say it will be pointing to the starting? It will. Only if there are 1's. Only if there are 1's. We will look at the code. Don't worry. But as of now, remember, the last of 0 will be pointing to the starting of 1's only if there are 1's. And where will the last of 1 point to? To the starting of 2 only if, I repeat, only if there are 2's. And this 2 will be pointing to null, which is very obvious, right? So I'll be writing down the pseudo code, and in case you want the C++, Java, Python, JavaScript codes, the link will be in the description. So what will be the initial thing that we need to write? What if the linked list is empty? We don't need to sort it. What if the linked list has one element? We don't need to sort it. So make sure you write down these edge cases where if the head is null, which means it's an empty linked list, or if it is a single element linked list. In both the cases, you will return whatever is given to you. Please return whatever is given to you. Apart from this, what did we do? We took a dummy 0 head. We took a dummy 1 head. And we took a dummy 2 head. Right? And maybe you can say new node of -1. Depending on the language that you're using. New node of -1. It can be any value, not necessarily -1. It can be -50. As long as it is not 0, not 1, not 2. It is okay. Done. Apart from this, what did we do? We also took a 0 which was pointing to this 0 head. We also took a 1 which is pointing to the 1 head. Perfect. We also took a 2 which is pointing to the 2 head. And this was used for traversal, right? After that, what did we do? We took a temporary which was pointing to the head. Perfect. And now we will be traversing. So that basically means while temporary not equal to null, because that is what the traversal means. What do? We have a check. What if it's a 0, right? So let's have a check. What if it's a 0? Temporary data, if you're a 0, we will do something different. What will we do? We will take 0's next and we will point to temporary. That's what we did. If you remember properly, this is what we did. We simply pointed to the temporary. Once you've done this, you will say 0. Can you now go to the next? 0, can you go to 0's next, which is basically temporary? So you can straight away say 0, can you go to temporary? You basically moved the 0. What you did was, you connected, then you took the 0 and you took it ahead. Once you have done this, the temporary, if you remember, it moved ahead. So let's move the temporary. Temporary will always move. Maybe we can do it afterwards. As a common step, we can. Done. What if it's a 1? What if it's a 1? In that case, very simple. 1 dot next will be temp and 1 will be temp. Perfect. Or else 2 dot next will be temp. It's super easy, isn't it? And 2 will be temp. Once the conditionals are done, once you have segregated the node, connected the node, what is your next job? Make sure temporary goes to the next, because I'll have to go to the next node. And the while loop completes. So this will make sure, this while loop will make sure you have this, and you have this. After this is the main job that you will have to do. Tell me one thing. The 0's next should be pointing to this one, which is basically 1 heads next, right? What if I don't have anyone? In that case, I will just have the dummy 1 head. I'll just have the dummy 1 head. And the next will be pointing to null. And the next will be pointing to null. So I cannot point this 2 here. Because if it doesn't have any 1, then the 0 will be connected to 2. Agreed? So can I say this? Right after this, I need to make sure 0 is connected, right? So can I say 0? Because 0 is the last. 0's next will be if 1 head of next is there. If it is there, if it is not null, then I will connect it to 1 head dot next. Basically saying, why 1 head dot next? Because 1 head is your dummy node. The next is your first node. Remember? So this is what I'll do. Make sure 0's next is connected to 1 head's next, which is this. Perfect. But what if this is null? Then you will say, hey, can you go and connect to 2 head next? You might have one more question. Hey, Striver, what if there is no 2 head? What if I don't have 2's, I don't have 1's? It's fine. In that case, this will be pointing to null, isn't it? This will be pointing to null. So basically 0 will end up pointing to null, which is okay. If it doesn't have 1's, if it doesn't have 2's, it will eventually point to null, which is okay, right? I just need to make sure if there are no 1's, I connect it to 2. 2 can be null. I don't mind, because if there are no 2's, I will connect it to null. Might be thinking one more thing. Hey, Striver, what if there are no 0's? In that case, the dummy 0 head will be pointing to this. Fair enough. Okay. If there are no 0's, it will be pointing to this, which is okay, because 0 will be here and 0's next will be pointing to this, or 0's next will be pointing to this, which is okay. Doesn't matter. We've understood this. So we have done the job for 0. We have made sure it is either connected to 1 or it is either connected to 2. And if they are null, it will be connected to null. What is the next job? It's for the 1. So can I say 1 next is what I'll have to think of? Okay, let's see. The next should be connected to this. Should be, which is basically 2 heads next. Just write it. 1's next will be connected to 2 head next. Why 2 head next? Very obvious. 2 heads next is this one. So it should be connected to this. What if there are no? Fine. If there are no, that's fine. It will be connected to null, which is okay. Right? Okay, fine. What if there is no 1's? In case there are no 1's, the 1 head gets connected to this, which is okay. I don't mind. So all the cases are covered. You can take pen and paper and you can try out. What is the next job? It's for the 2. 2's next, no matter what it is, it will always be null. It will always be null. Because the last will be pointing to null. Because the last will be pointing to null. What if there are no 2's? Fine. The 2's, this one will be pointing to null. Doesn't matter. Doesn't matter. Once this is done, what is your job? Your job is to get the new head. And what will be the new head? Can I say the new head will be the 0 dummy head that you took? That's next. Can I say this? I can. Why? Because either this one will be your new head, or else if this is pointing to this, that will be a new head, or if this is pointing to this, this will be a new head. That's why I said, even if this is empty, let it point to this, it's fine. Let it point to this, it's fine. Because these will be the new heads if there are no 0's. So the new head will be this one. You can return the new head. And in case you're using C++, need to free, right? So make sure you delete all the dummy heads that you take. All the dummy heads should be deleted. Please make sure you delete all the 3 dummy heads, which is basically this one, and this one. You free up the space. Done and dusted. I know you might still be thinking about this. Take a pen and paper. Take multiple examples. Take examples where you just have 0's. Take examples where you just have 0's and 1's. Take examples where you just have 1's and 2's. Try with all examples and you will understand these things in much, much deeper way. This is how I did learn. I used to take pen and paper, just wrote down multiple examples and then figured out, okay, it's working. That's how you learn, okay? What will be the time complexity? Can I say this is nearly big of n, nearly, not exactly big of n, because I'm doing a single traversal. After this, these are link changes, so I won't count it. So can I say I'm actually doing it in big of n? I'm using the same nodes, so big of 1 space complexity. Indeed. So I've optimized the 2-pass solution into a 1-pass solution. So let's quickly check out the code in the code editor. As you can see, the edge case is written right at the start. After that, the dummy nodes. Right after that, the nodes for traversal. We traverse, right? After that, the linking of 0 to 1 to 2. The new head. And make sure this is just for C++. You delete, you free up the space. Once you've done this, you return the new head. And I'll hit the submit button. The Java, Python, JavaScript codes are pretty much similar. You'll find the code link in the description in case you want to have a reference for it. So if you're still watching, I'm very, very sure that you've understood everything. And if that is the case, please do consider giving us a like. And if you're new to our channel, do consider subscribing to us as well. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.
Whenever your heart is broken.